Now let's do question 23, and this is an inequalities question. So it says, by drawing suitable lines and shading unwanted regions, find the region R where x is greater than or equal to 2, y is greater than or equal to x, and 2x plus y is less than or equal to 8. So the first step is that we need to draw these lines. And to draw these lines, you need to assume that these are not inequalities, but equations. So instead of x greater than or equal to 2, you need to draw x equals to 2. Instead of y greater than or equal to x, you need to draw y equals x. And instead of 2x plus y less than or equal to 8, you need to draw 2x plus y equals 8. So let's draw first x equals to 2. So x equals to 2 is straightforward. So it's just a vertical line intersecting the x-axis at 2. So let's do that. So I'm going to draw a vertical line. Again, I'm not using a ruler, so I'm trying to do my best. So a straight line intersecting the x-axis at 2. So this is the straight line. So it's actually good. Now, let's do. So it should continue till here. Yeah. So that was x equals to 2. Now how can we draw y equals x? Now to draw y equals x, simply you need to construct a table of values. And to do that, so here I have y equals x. So we need to think about it. So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3, and so on. So we need to plot these points. So when x is 1, y is 1, so it's this point. When x is 2, y is 2, so it's this point. When x is 3, y is 3, so it's this point. When x is 4, y is 4, and so on. Now we need to draw a line connecting all these points, so let's do that. And that way, then this is my line. Now, the final equation is 2x plus y equals 8. And let's do that as well. So 2x plus y is equal to 8. So I'm going to make y the subject because it's easier for me. So it's 8 minus 2x. And to draw that line, I need to construct a table of values. Here I have x and y. So when x is 0, y is 8. When x is 1, y is 6. When x is 2, y is 4. When x is 3, y is 2. And when x is 4, y is 0. How did I do that? Simply I substituted each x value into the equation. So for example, when x is 2, it's 8 minus 2 times 2. So 8 minus 2 times 2 is 8 minus 4, which is 4. And you do that for the rest of the values of x. Now let's plot these points. So when x is 0, y is 8, so it's this point. When x is 1, y is 6, so it's this point. When x is 2, y is 4, so it's this point. When x is 3, y is 2, so it's this point. And when x is 4, y is 0, so it's this point. Now we need to draw a line connecting all these points. So it's this line. Let's repeat. So it's this straight line. Now let's start shading. Now after we drew all the lines, let's shade. Now the first inequality is x is greater than or equal to 2. So x greater than or equal to 2 means the values of x are greater than 2. So that's what the question wants. Values of x greater than 2. So the unwanted are values of x less than 2, which means everything to the left of the vertical line. So I'm going to draw that or I'm going to shade that in purple. So that's the shaded region. It's this area. Now let's do y is greater than or equal to x. So y is greater than or equal to x. It means everything above the line y equals to x. And that's what the question wants. And the unwanted region here is everything below the line. So I'm going to shade everything that's below the line under the line y equals x in yellow. Now, what's left is 2x plus y less than or equal to 8. Again, it's less than means everything below the line. So the unwanted region is everything above the line. So I'm going to shade that in a different color. Let me choose blue. So it is everything above. So it's this region. So the region that's left unshaded is actually the unwanted region. So I'm going to label that with R. So it's this small triangle here. Now in part B, it says find the largest value of x plus y in the region. Now to find the largest value, you need to pick a value of x and a value of y. When you add them up together, the answer is a maximum. So it's a maximum value. Now, so this is all about trial and error. So after many trials, the value of x, which is 2, plus the value of y, which is 4, will give me the maximum value, which is 6. Now you can try different points, different x coordinates and different y coordinates, add them up and check your answer. However, you will reach to a point where you will figure out that the max value is when x is 2 and y is 4. Now, question 24. So it says the diagram shows a sector of a circle of radius 8. The length of the arc is 6.4, so arc PQ. We need to find the area of the sector. Now, the formula for the area of the sector A is theta over 360 times pi r squared. Now, the radius here is known, it's 8. And pi is a constant. So I need to find theta. So once I have theta, I can find the area. Now, how can I find the angle theta? Now, I'm given that the length of the arc is 6.4. And we know that the length of the arc is theta over 360 times 2 pi r. So the length is 6.4 equals to theta over 360 times 2 pi r. So 2 times pi times the radius, which is 8. So it's equivalent to 16 pi. Now I'm going to cross multiply. So here it's 360. So 360 times 6.4. Let's calculate that. It's 2304. Equals to theta times 16 pi. So to find theta, I need to divide by 16 pi, and of course the left-hand side by 16 pi. So 16 pi is basically 50.24, so the answer is 45.9. So theta is 45.9. Now to find the area, I need to substitute theta into the formula for the area, so it's 45.9 over 360 times pi times 64, because the radius squared is 8 squared, which is 64. So the answer is equal to 25.6. So that's the area of the sector. Now, in question 25, so it says simplify 2x squared plus x minus 15 over ax plus 3a minus 2bx minus 6b. So the thing here is that we need to factorize the numerator and then I need to factorize the denominator and then simplify. So let's factorize the numerator. So 2x squared plus x minus 15. Now whenever you have an expression of 3 terms, then the correct method to factorize is called the quadratics method. And this method is basically the following. So I need to find the values of a, b, and c, where a is the coefficient of x squared, which is 2, b is the coefficient of x, which is 1, and c is the constant, which is negative 15. And then I need to find the value of AC, which is 2 times negative 15, and it's negative 30. So once I have AC, which is negative 30, you need to think of two numbers, or of two numbers. When you multiply them, the answer is negative 30, and at the same time, they add up to b, which is 1. These numbers are 6 and negative 5, because 6 times negative 5 is negative 30, and 6 plus minus 5 is 1. So let's rewrite the expression using the two factors. So it becomes 2x squared. So instead of x, I'm going to write it as 6x minus 5x, because 6x minus 5x is x. So instead of x, I wrote x in terms of the two factors, minus 15. Now, this is an expression of 4 terms. And whenever you have an expression of 4 terms, then you need to use the grouping method. So I need to group the first 2 terms and the second 2 terms. Now for the first 2 terms, I have 2x squared plus 6x. So what's common here is 2x, and what's left inside is x plus 3. Now I'm going to repeat the same bracket, which is x plus 3, and outside I have negative 5, because if you expand, negative 5 times x is negative 5x, and negative 5 times 3 is negative 15, which is correct. Now, the factorized form is basically 2x minus 5, so you need to combine your answer and x plus 3. Now let's factorize the denominator. So I have ax plus 3a minus 2bx minus 6b. Again, since this is an expression of 4 terms, then the correct method is the grouping method. So I need to group the first 2 terms and the second 2 terms. Now for the first 2 terms, the common factor is only a. So you need to take a outside, and inside the bracket you have x plus 3. Then you need to repeat the same bracket, which is x plus 3, and outside you need to write negative 2b, because negative 2b times x will give me negative 2bx, and negative 2b times 3 will give me negative 6b, and that's correct. Now just combine your answer, so it's a minus 2b times x plus 3. Now to simplify, now the factorized form of the numerator is 2x minus 5 times x plus 3, and the factorized form of the denominator is a minus 2b times x plus 3. Now to simplify, you need to cancel x plus 3 with x plus 3, so the final answer is 2x minus 5 divided by a minus 2b. So that's the simplified form of this long expression. Now, in number 26, so in this question, we're given that the cubic root of y squared is the same as the square root of x to the 1/6, and y is the square root of x to the 1/nth. We need to find the value of n. Now, the cubic root of y squared, it can be written as y to the power of. Now, the tail usually goes to the, or into the denominator, and the power here is basically the numerator. So y to the power of 2 over 3 is the same as the cubic root of y squared. And x, or the square root of x, and here I have 6, is the same as x to the power of 1 over 6. Now, since this is equal to this, I can equate this to this. So y to the power of 2 over 3 is the same as x to the power of 1 over 6. So how can I find y? I need to multiply the power times 3 over 2. So the 2's and the 3's cancel out. and of course 1 over 6 times 3 over 2. So the answer is x to the power of 1 over 4. So y, so this is y. So y is equal to x to the power of 1 over 4, and this can be written as the square root of x, and at the tail I write the denominator, which is 4. So what's n here? It's 4. So the value of n is 4. Now let's do the last question of this paper, and it's question 27. So this is a 3D shape, so it's a cuboid. AB is 8, AD is 6, DH is 6. I need to find the angle HAF. So it's this angle. I'm going to call it X. So this is my triangle. This is X. This is point A. This is point F. This is point H. Now to find angle X, I need to find the lengths of the three sides, HA, HF, and AF. Now how can I find AF? Now if this is 8 and this is 6, so this is 6 because it's a cuboid, and this is 6. Now if I draw this triangle, this is 8, this is 6, how can I find AF? And here is B. So since this is a right angle triangle, I can use Pythagoras Theorem. So AF squared is equal to 8 squared plus 6 squared, which is 100. So AF is the square root of 100, which is 10. So I found AF, which is 10. Now how can you find HA? Again, this is a right angle. We're given the length of DH, which is 6, and the length of DA, which is 6. So HA is basically the hypotenuse squared is equal to 6 squared plus 6 squared, which is equal to 72. So what's HA? It's the square root of 72. So HA is the square root of 72. Now finally, how can I find HF? Now if this is 8, then this is 8 too. And if this is 6, then this is 6. So this side is basically 10. How did I get 10? It's basically this side squared equals to 6 squared plus 8 squared, which is 100, and the square root of 100 is 10. So again, the same as the previously drawn triangle. So basically you need to use Pythagoras Theorem here again. So this is H, this is E, this is F, and this is HF, this is 8, this is 6. So HF squared is equal to 6 squared plus 8 squared, which is 100. So HF is 100. Is a 10, sorry. Now we're given a non-right angle triangle with 3 known sides. And whenever you have a non-right angle triangle with 3 known sides, to find angle X, it's the cosine rule. So the cosine rule states that it's the side that is opposite to your angle in the question, which is 10. So 10 squared is equal to the square root of 72 squared plus the other side squared, which is 100. It's 10 squared minus 2 times 10 times the square root of 72 times cosine the angle X. So to find X, I want to move this whole thingy to the left and 10 squared to the right. So it becomes 2 times 10 times square root of 72 cosine X equals to now the square root of 72, all of it squared, is the same as 72 plus 100 minus 100. So these cancel out. Now here I need to divide by 2 times 10 times the square root of 72, so that I can cancel out the numerator. And of course here by 2 times 10 times the square root of 72. So using your calculator, just evaluate 72 over 2 times 10 times the square root of 72, and the answer you get, just apply the cosine inverse, so the inverse function of cosine, to find the angle x, and x is 64.9 rounded up to 1 decimal place. So that was the last question, and this is the end of paper 2, May-June 2020, extended.